All right, hello everybody. I hope you can hear me. I'm really sorry I can't see anyone because the room is really dark and the lights are shining. So if you've got any questions throughout, you might want to wave or just save them to the end. So thank you very much for coming. In case you're wondering, the accent is Scottish, and I'm really sorry if I hope everyone can understand me. I tend to put people to sleep, but hopefully you'll be so excited by machine learning and deep learning that you won't get the inclination to fall asleep during the session. My voice is soft and relaxing, and the room's dark, so I get it, you know. Some of you will have been out last night as well, so I get that too. All right, so in this session, we're going to look at deep learning. So I must admit, I wrote this abstract a very long time ago during the speaker process. And at the time, there was a lot happening in the Cognitive Toolkit and also with CaffeOnSpark. But what I've seen since then is I don't see Microsoft doing very much in CaffeOnSpark. And I've seen lots of other new technologies that they are using. They announced a lot of machine learning things last week. So that if you don't mind, I'll focus on those other items instead, the new stuff, because I don't know about you, but I'm always trying to work out, it's like a bet, which technology should I go for? So I give my customers longevity in their solutions as well. I want to try and give them something future-proof. So I hope that will be something that you'll be able to make a difference with your customers today. So who am I? My name is Jennifer Stirrup. My background originally was artificial intelligence, and then Y2K came along. Yes, I am that old. Some of you might remember Y2K. But I stuck with AI and everyone became Y2K consultants. Then Google came along and they rebranded artificial intelligence as search technologies. And AI entered one of its very many winters, where it becomes exciting and then everyone ignores it. So now it's actually AI and machine learning, it's all cool again. So I've waited this long to be cool, so I'm really enjoying it. It's been a very long few decades. So I'm happy for you to take photographs or anything of the decks at any point. There's my contact details. I accept LinkedIn. I'm on Twitter, probably too much on Twitter, not Facebook so much these days. And I'm a Microsoft regional director and a most valuable professional, which probably really means that I just like the sound of my own voice talking about technologies that I really like. Okay, so as a developer, why should you care about AI and ML? The very short answer is that's where the industry is going, and it's a fantastic skill set to add on to what you have already. So when you come back next year and you're all earning megabucks because you're doing AI and ML as well as what you do already, mine's a red wine, and I don't know what anyone else is having. So I think it's a really good place to be, and it's all ands. So what is artificial intelligence? It's one of these things. I'm going to talk a little bit about definitions because I tend to find that people use the words to mean different things. So AI is really the field of making computers think and perform tasks which is inspired by human-like thinking. So within artificial intelligence, there's two main streams. We get general artificial intelligence and we get an applied, much more narrow artificial intelligence. And with the general artificial intelligence, we're thinking more about the Hollywood interpretation of AI there, Terminator, iRobot, these kind of things. So what we're actually looking for with Microsoft technologies is the narrower definition of artificial intelligence, where we think about technologies that are probably already in your smartphone, things like Alexa and Google, Cortana, voice recognition technologies. Now, these technologies are very good at one thing, and they're inspired by human-like thinking in order to do one thing really, really well. So that's what AI is. Now, machine learning is different. Machine learning doesn't necessarily have to be inspired by human-like thinking. So the reason that I mention these is sometimes people use the terms to mean the same things. So I'll talk about deep learning a bit later, but deep learning is a subset of AI. It's really about fine-tuning the algorithms so that they can actually respond really well to and be inspired by human-like thinking. And they've got different ways of doing that. So the reality is that some problems are really hard to solve using traditional algorithms. Think about our Xbox and Kinect. So the Kinect is trying to understand your body language when you're doing things. Now the nice thing about that is it's actually really flexible way of programming. You can't account for every single movements that the individual might make. So it has to guess, it has to use heuristics to shortcut and find out the answer very quickly. And that's what the Kinect is doing, so it's a little bit of AI. But it's very hard to do that with procedural programming because there's so many possible permutations. The search space is so high, it's difficult to do. So some examples where you might use AI that you run into all the time. Classification, so if a customer is a retention risk. Now, in marketing, you often find is that the companies are really interested in what it means to retain customers. Because when you lose a customer, it's actually really, apart from the fact it's hard to get them back again, it's easier to retain a customer than it is to get new ones. So people are interested in the data. It's all about data. We're identifying objects and images and videos. There's a really nice example recently where someone set up an algorithm to identify Chihuahua dogs versus blueberry muffins because it kind of looks the same same colour with sort of little dots on them. So people, okay, it's a bit of a waste of time, but it's the sort of thing that visual recognition is trying to do. Detecting defects in an industrial process. So there's examples of that, trying to do predictive maintenance. So what projects are good for machine learning? I tend to look at the ones for my customers which are all about automation, the last mile. How can I take a business process and make it smoother? So one example I've got of that at the moment is one of my customers is we're going to use AI to transcribe handwritten forms. And the reason we're doing that is there's a team already, and the team, their job is actually just to take these handwritten forms and type out the detail and whatever people have written in the forms. So that team is still going to be there. We're not getting rid of jobs. It's not about that. It's about smoothing the process so the AI can read the easier forms, and the humans, the team, will be able to read the forms and transcribe those, the ones that are a bit harder. So in a way, using AI takes more advantage of our human capabilities. I don't know about you, but my handwriting's terrible because I never write anymore. I just constantly typing. I even e-sign documents, so I don't even do that. So when I do write something, my handwriting's awful. And I think there'll always be a space for AI complementing existing human capabilities, making our lives a bit easier, and who doesn't want that? So when can we use machine learning? So in the example I just gave you, something that's very repetitive is a good candidate for machine learning. Also, if you're not sure and can't explicitly program something, using heuristics is a good idea for that. And also another example is where you've got lots of data, trying to find lots of patterns in that data. Now, one example I've got of that is a project I did last year for one of the London councils. We were trying to understand homelessness better, what led people into homelessness, and also could we predict if someone was likely to become homeless. Now, when people become homeless, obviously it's very difficult circumstances for them, and it's actually the largest group of homeless people is women and children, believe it or not. They usually tend to leave because of things like domestic violence, so they are in horrible situations. The thing is, it really affects children's education as well, because the emergency housing they go to could be 6 miles away from the emergency housing across London. So it's really hard for the parent to take them there. So it affects all sorts of things. So the project was coming from a good place. We were trying to help people and catch them before they fall into that awful trap. So that was what we did there. We used Microsoft technologies for that. So we used SQL Server, we used R, and we used Power BI in order to explain and show these difficult concepts to people who had expertise in housing and the law, but not necessarily any technical background at all. So there's all sorts of different ways that AI can be used in order to help people. you might see from my laptop stickers. But I do a lot of work for a charity called DataKind. This is a shameless plug, I guess, for the charity. But if you're interested in working with data and don't know where to start, people sometimes feel I don't have experience, I can't get into this. I found that sort of when I do work with DataKind, what we do is we get data scientists of all levels and abilities, and we get charity data, and we see what the data scientists do with the charity data. And the charities we've worked with have really, really benefited from having the assistance of the data scientists. Data science is an expensive skill. AI and machine learning, they're all expensive skills. Charities don't tend to have access to these. So an example we looked at was stem cell research. So when we have a stem cell register in the UK as part of the European initiative for that. And when someone's asking for donors in a stem cell register, they're not in a good place. So it's about trying to help and understand how we can attract and retain donors so it starts to become an AI issue. And it's great fun as well. So if you feel that you want to get started, we had 2 women turn up and they just knew Excel, as they put it. But they said, your charity helped my nephew, and we just want to be here and do something. So there's all sorts of opportunities to get into this that have a really good social impact. So that's some things that I've been working on. And it really does make a difference. And these charities tend to have lots of data. So Microsoft have got great examples as well. So ABB, for example, are using AI in their workforce management. They're using Azure Cognitive Services to help connect their mobile workers all around the world much more efficiently. And as a result of that, they're seeing a 20% increase in customer satisfaction. It's all about the customer. I'm doing my MBA at the minute. I don't know why I'm asking myself that a lot. But I'm struggling my way through it, but I'm really enjoying it. I'm learning so much. Because as a consultant, I work for myself, and I want to be able to ensure I can advise people in the best way. And what I'm finding is customer satisfaction, the best companies are the ones that focus just on that, not necessarily what the competitors are doing. And using your data properly, there's so many patterns in that data that can really help people, and it's about being imaginative, I think. So a few ways to get started. So I tend to find this can be, because people get different definitions of AI, machine learning and deep learning, they basically want everything, but they don't know how to get started. So customers tend to only do ands. They have a weird type of logic. They never do ors. They never do nots. They just want everything all at once. So how do you manage that? What I tend to do is I run very small proof of concept projects. I'm running one at the minute. And the proof of concept project is taking an achievable, small business problem that I can automate, show success, and then move forward from there. It's easier to prove a series of small successes than it is to try and do a really big project which fails in the middle. It's a bit like baking a really big cake. It's going to fall in the middle. And that will put people off the technology. They tend to blame the technology rather than blaming the people or the process. It's just that's what people do because it's easier. But the reality is people will do the same stupid things with a different technology, so it's about trying to get them to a successful place. So this message is probably not popular, but the first thing to do is about preparing your data. And what I mean by that is cleaning the data, identifying the data sets that you've got. Having a data dictionary or a data glossary is a very good start. I've been in IT for about 20 years, been a consultant for most of that, worked for myself for the past 8. And I've only come across 3 companies that have got a data dictionary, and even then, they've been pretty miserably out of date. So it's the sort of thing where if we are going to be really data-driven as an organisation, we have to think about the stuff that's not really quite as trendy, such as preparing data. Just cleaning it, looking for missing data. The reality is, in psychology, we get something called the bystander effect. So it really means that people see a problem, but they all think that someone else is going to solve it, and the data suffers from a bystander effect. It's always someone else's problem. It's the business's problem for not entering the data properly. It's IT's problem for not looking after it. But we have to try and adopt it as an organisation. I look at it, we've got a term in IT called technical debt. I'm sure you've heard of that. I look at it, I call it data debt. What is the data debt that we can capture, wrap up and do something with? And I try, and in every project I do, try and inherit some data debt so we can resolve it. So we show success. Now, the difference between programming normally and programming with AI is there's a big sequence in the middle where we build our model and then we have to train it, then we deploy it, is normally what would happen. But then you have to keep going back, training, making sure it's working successfully and looking after it. With a lot of programs, I think sometimes once they're delivered, going into production, the box is ticked and people move on to different things. But with AI and ML, because it is introducing heuristics into the situation, you need to just try and make sure that the AI, the ML, what you've built, is keeping pace with the data that you're throwing at it. Because the reality is data changes all the time, customer requirements change all the time, and because of the data, you need to keep on top of it. So that's why we talk about building and training models. Deploying is the last mile problem. I tend to find organisations start to build all this stuff, they get excited, but no one really wants to press the button to put it into production. So have we done everything? And once you do that, it's about reassuring organisations to stay on top of it. So you can deploy the service to the cloud, you could just deploy it to Azure, for example, or deploy it to the edge as well. So there's a few different technologies that Microsoft have got. Hope you can read that all right. Azure Cognitive Services involves things like facial recognition, speech recognition. They've got some really cool things happening there. The Windows AI platform is you can use that for things like sentiment analysis. People want to look in Twitter and see if there's bad things been said about their company. And then you've got ML.NET, which you can use in Visual Studio. It's an add-on you can go and download. There's a component in preview at the moment, so you can go download it and play with it. But the idea is that you can use AI and ML in your existing applications, and you're just calling the module and putting things together. So it's improving what you've got already. Okay, so what I'm going to do is I want to show you very quickly Azure Notebooks. I'll come back to some of the ML stuff. But I don't want to PowerPoint people to death. It's a very warm room and cosy. I don't want you sleeping. So how can you really get started with all of this technology? What I'd like to do is there's so many different ways to get started, and I think we can dive into Visual Studio and things like that, but sometimes it can be quite hard to install these things. Python isn't always easy to install with environment variables, and I think sometimes that can start to put people off. So a really good way just to get started is called the Azure Notebooks. Now I'll show you how these work and how they set them up. The main idea is that it's a notebook hosted in Azure, so if your data is already in Azure, you can go and start to make the most of it. The notebooks are written in Jupyter, which are based in Python, and the really cool, nice thing about this is, apart from it's in preview, so it's free at the moment, is when you create a notebook, it sets up a kernel for you. It can be in R, it can be Python, it can be F#. So the nice thing is you can, if your data is in Azure, you can just go and get started straight away playing around with it. The other nice thing about it is there's so many different technologies that you can use, and there's loads and loads and loads of examples. It's in GitHub, obviously Microsoft own GitHub now, so if you're interested in Azure Notebooks, even Azure Cognitive Services, these technologies, go and have a look in GitHub, go and try these things. The one that we're going to look at is Tensorflow. I'll explain briefly what that is. Now, it probably seems a bit strange why we're talking about Tensorflow, because it's open source, it's also in Google, but what I find is when I look at data science and AI projects is industries and companies tend to have a real cottage industry of lots of technologies, lots of different things. And usually they have a bit of everything in there. But what I try and do is streamline a process. So by having it in Azure means that I can actually streamline a process. It's easier for the support teams to look after because you're trying to bring everything more into one place, but still balance it with the fact that they have got whatever technology they want running in Azure. The reason we're looking at TensorFlow in particular is because I see this one and being adopted more and more and more. So just with the takeaway point here is that you can have this technology and you can have it in Azure. And I think that's really nice. It helps the people to look after it better because it's more in one place. So we'll go through the demo and then we'll go back through a bit more about some of the concepts underlying TensorFlow. But first I'd like to show you these notebooks. Now what we have first of all is they tend to be organised together in projects. So I'll set up a project so you can see it. So this is me, I've actually logged in and I've got the home page just here. I've set up quite a few projects as you can see actually. Then we can look at all the projects we've got in place. So I'll just use this one. Oops. So I'll just use this one down the bottom, the getting started one. So you can go and clone this if you like from GitHub, and there's a nice way easy way of doing that. You can download a project if you like. Oops. So I'll just cancel that. The other thing you can do is upload as well. So if you want, you can upload anything from a URL. So you can start to add in GitHub URLs in there, and it basically what will happen is the Azure notebooks will go and get the solution, the program from GitHub, and import it into Azure notebooks. I'll show you how that works. So what we've got here is I'm going to import this one, which is the TensorFlow one. So it's up in GitHub. So all I need to do is take the URL, post it in there, and off it goes. I'll give it a better name so I can find it later. So it's going to go and upload it. Oops, target URL. So when we go down, we can find some of the tutorials in here. And what we've got, I've got one uploaded already, so I'll just use that one. So first thing we can start to do is we can have a look at our notebook here. So I'll just open this example here. So I'm just going to zoom in so you can see it a bit better. Oops. Right. So what we've got here is when we go to the kernel, I'll just zoom in so you can see that a bit better. Here's the languages that you can have available to you. And when you set up the notebook, you can have F#, you can have Python, or you can have R, and you can start to change these as well if you like. And this is what they actually look like. It's different from normal programming in terms of the layout because it uses the cells, and basically you just put your cursor in, and then you can start to run the cells. So the nice thing is when you deal with data, it's a bit different because you've got your comment, you've got your code, then you've got the results. The nice thing about it, I think, is it allows you to program in a way that's not very linear, because when you're dealing with data, you don't always know what you're going to find. There's usually surprises in there somewhere. So it means you can try something, see how it works, maybe look at how clean the data is, and then try and go down a different path. But it does mean you've got all of your results, so you can see where you were going. So I don't know about you, but when I'm working with data, I can really see that we've gone down a rabbit hole sometimes. It's very, very easy to do that with data, so you need to come back up again and try a different route. And I think that's why the notebooks are such a nice way of trying to organise the packages and things and how everything hangs together. So here's some of the code here. So when we set up Python, for example, you can actually import some more Python libraries. So these are quite well-known ones. Matplotlib, it's always hard for me to say, is you can use that for data visualization. So NumPy is allowing you to do interesting things with the data. It's very good for helping you to crunch through it. Another thing to notice here is you can start to import AzureML. So we're starting to import libraries and things straight from Azure. And what we do is we can set up a workspace as well. These workspaces can be set up in the Azure portal, and I'll just show you how that looks. So we need to set up some variables, and we'll have a look at that. So you can basically tie the Azure notebook and the Azure portal together, just so all the resources, so they know about one another. Oops. So when we start to play around with our projects, we can start to set up the notebooks and have different programming languages all in one place. So if you're interested in getting started with it, it's a great way to get started. Okay. So what I'd like to do here is just show you a quick way. I never trust conference Wi-Fi, so I've started to record things, so that's why. So the first thing you have to do is you can get a free account, obviously from Azure. You obviously can set up paid accounts as well. But the first thing to do is set up a machine learning workspace, and we give it a name. So I'm using the name Red Queen here. The reason for that is you might have read the book or seen the movie Alice in Wonderland, and there's a book. The second book is called Through the Looking Glass, and there's a bit where Alice is running in this spot under the tree, and the Red Queen says, if you want to move forward, you'll have to run twice as fast as that. And I feel like companies with their data feel that they're running in the spot, not really able to move forward. So that's where it comes from. So we need to set up our ML workspace, first of all. So that's just deploying that item there. So once we've done that, we can go to the resource in Azure portal. We have our workspace set up. So what we can start to see straight away is we've got examples in GitHub down the bottom. And you can also start to explore the workspace. That will bring you up an automated Azure notebook. So we can go to, and it'll give you one that's already pre-set up for you. So everything's in Azure. So if you've got any experiments set up as well, we can see everything is just laid out, even though it's data science using AI. Everything's very much in the Azure portal, so it's easy to see. So here's the example. We've got, we're going to clone one of the libraries to get started. We're just going to call this one Red Queen. So we clone that one. And then it'll take a minute or two. It'll go and get what we're looking for. So the configuration here, these details are actually coming, these are the ones that you need to tie the Azure portal and the libraries together. You need your subscription ID, they need the workspace name as well, and you need the name of the resource group. So these are easy to get. We can start to see these from both of the portal. So then we need to go back and copy the subscription ID and the Azure portal together, just so they're connected. So what we can see here is we can start, these are in the Getting Started notebooks. So these are installed by default when you set up the machine learning workspace. So what we can do then is we've got our Python notebooks installed as part of the library. So here I'm creating an experiment. The first thing we do is just run some of the cells. These are importing services from Azure, also importing our data from Azure as well. So if your data is in Azure, you can start to go and import that data and bring it down. So what we see here is when we interrogate the notebook, we're asking it for the resource group, for the work group name, and these match exactly what we've got in the Azure portal. So there is that connection there. So if you're already using the Azure portal, which you probably are, all of this technology is in there just to go and play with it and get started. We've got a resource group and the location is South Central. So everything matches. So then we can start to import some more technology items here. So we've got the Azure telemetry option. That will tell us interesting things about how the machine learning workspace is working, and we can use that for diagnostics as well. So the example that we've got here is we're actually going to load in one of the default Python libraries, which is actually a lot of image data. And the image data is all about trying to guess if something is a 3 or a 6 or a 9. It sounds like maybe a silly example, but if you've seen my handwriting, it's really hard to decipher. So we're going to try and get the machine learning algorithms to do this instead. So there's so many different models that you can use in Azure Machine Learning, you can use in Azure Notebooks. It's sometimes very, very hard to determine which one you should use. Now, Microsoft have released this really great package, which is called AutoML. So if you're just getting started on this path, I really recommend you look at it. The nice thing about AutoML is it takes your data and tries to work out which model would be the best one to suit your data. So basically, it's very meta. It's almost trying to do AI on AI. So you try and give you whatever model it thinks that you need. So what we see here is I'm actually calling AutoML. I don't know if you can see that, I'll just zoom in. The AutoML configuration, I've actually set it just to use classification. And what it's going to do is it's going to try and throw the data at lots of different pipelines. So it's got lots and lots of different pipelines that it can try and use to work out what model would be best suited for your data. So some of these are quite well-known ones. We've got some of the classifier algorithms in there. It's actually based on scikit, which is one of the Python deep learning libraries. And we can use that with Tensorflow as well. So I'll just move that forward. So basically, it's actually quite fast. So I'm just obviously videoed this, but you can see how quick it is at trying to take a sample of the data and throw the model against it. And it will try and do that for all of the models it thinks are correct. So I'll just move that forward. So we can see here that the metric, because it's sample data, is coming up with some really, really great results. And you'd expect it to, because it's just a demo, but the thing is, in real life, you wouldn't see those results. But what it's trying to do here is give you the best one. So it determines that the best one is 0.99. And basically, 1 would be perfect, and 0 would be terrible. So that's why it's coming up with that. But what I think the takeaway point here is actually just with a few lines of code, you're calling all of this the power of Azure and the power of AutoML, and it's working out the models for you. You're not having to do an awful lot of programming or trying different models yourself. It's a good starting point. So what we can see here is eventually we'll try and work out what the best one is. So it's going to try and run these locally. I'll just move that one. Okay. So we're running it again this time, but this time it's going to find one that it thinks is perfect. And that one is actually going to be the min-max scalar, and I'll show you what that one actually means. So here, hopefully you can see that, but eventually finds one that it feels is a perfect match. So they see the best as being a 1 here, and we can see it's only taken seconds to work that out, so it's actually really powerful. So it'll get you on your way quite quickly. So it's found the best one. And basically the objective is it's trying to find the best classifier to classify handwritten digits. So that's an example where you might see you've got pictures of images and you want to classify them. So storing that data in Azure is a really good way to get started, and it's using the min-max scalar. So I'll show you what that looks like. So the next step is we talked about building and then training the model. So what we've tried to do is lots of pipelines. It's now going to try, in the example, to use the best one. So it's testing the best fitted model. So it believes that's min-max scalar. So what we see here is in the photograph, it's got the label value is 6 and the predicted value is 6. So actually it looks kind of like a 6 and it doesn't look too bad. They normalise the images to try and make it easier to try and work out what they happen to be. So then we've got the label value of a 3 and it's predicted that one as being a 3 as well. So basically it's just going to give us a sample image. It will tell us what it thought the image was and what the label is of what it actually happens to be. So we can see at the bottom, the label value is a 5 and it predicts that it would be a 9. So it's not always getting it right. The top one's a 4, and then the second time we see the label value is a 5 and the predicted value is a 9. So it's still not quite getting it right. So that was just really a quick example. How you can get started, and the summary of that is using Azure Notebooks is a really good way to get started. You can call some of the Python libraries that will help you on your way. So it means you don't have to set a lot of things up. And that's the other thing with Azure Cognitive Services as well. What you're doing is writing your program and then try using the services available in Azure to go off and get that information for you. So there's a really good, it's basically giving you a platform and a good way forward to get started. You can use .NET, for example, because it's a great tech stack for building a whole variety of applications. You can use ASP.NET for using web development, using it there. You can use, obviously, Xamarin for mobile development, but with ML.NET, you're trying to make ML really, really useful for using machine learning and integrating it with other things. So with ML.NET, we need to write more code with that because it's in Visual Studio, but it provides you with the full machine learning lifecycle. So loading data, building a model, training and testing it, then eventually deploying it. It's also cross-platform as well, so you're not just bound only to Windows. It's also quite easy to use. The tooling's already in Visual Studio. So you also get two really important tools. One we just looked at is AutoML. We used it there in the Azure notebooks, but you can use it in ML.NET tooling as well, and it will try and work out what it thinks the best one is going to be. So AutoML itself is just an API, and it's accelerating that model development for you, because a lot of developers don't necessarily have that experience in data science. In the same way, a lot of data scientists are used to using R and Python for calculating and working out algorithms and performing the data science, giving you data back. They may not have much of the actual .NET programming experience that other people have for building the applications. So it's about trying to put all the pieces together. So with AutoML, the process of really trying to find the best algorithm is automated. So you've got the module builder as well, and there's some tutorials for that online. The module builder really is easy to understand visual interface, helping you to build, train and deploy custom machine learning models that would support your application. And it supports AutoML as well. So to summarise, there's a command line interface as well that will help you provide a product that would be a service to allow users to do all sorts of things. The example they give you here is predicting taxi fares, and that's one of the examples on GitHub. You can go and play with that one as well. Because it can be quite hard to know how to get started. So this would be the taxi fare example. I'm just trying to work out which one of the many models you could use, and something even like prediction could be quite a tough decision to make at the start. So there's so many algorithms you could use, and we tend to call those trainers. So linear regression, for example, is just a very simple starting place, a good place to start. And it's scoring whether something is above or below a certain point. It's a bit like throwing darts at a dartboard. How close are the darts to the bullseye? And it's helping you with that kind of scoring algorithm. So ML.NET is really about accelerating that data science, that AI model development phase, and also provides you with something called model explainability. The problem with model explainability is people don't always understand what's going on in the process itself. When you're trying to explain to business users what code looks like, that can be really tough for people who have got a business background. And it's something I see quite a lot. That's why I think Power BI is really useful, because it can actually help people to understand the data a bit more. They need to visualize it and they need to play with it so they can understand it. So what we can see here in this example, Model A on the left-hand side, is more sensitive to different features. So you could find that trip distance is very important to one model, Model A, whereas trip time is most important in Model B. It's about trying to explain the different models and their success. So it's actually quite a hard piece to explain how well the model's doing, and trying to visualise it even really simply like this is a good way forward. But AutoML itself is giving you the ability to choose different models based on its performance, and also try and explain the models back to you. So it's going to try and give you charts and graphs in order to do that. So here's what some of the code looks like. The first thing we need to do, the sequence is the same as many other programming concepts. The first thing we need to do is load the data. And then you need to initiate some sort of progress handler to track every model. So AutoML will do that for you. The next thing it's going to do is run AutoML. So again, I know it's not very clear. I'll put these up in my blog so you can see them. But the idea is that it's just a few lines of code to get you to a good place with the models. So once we pick the best model, then we can evaluate the model and test data. The first thing we do is build the model on test data first, on training data first, and then what we do is use a subset of the separate data as test data in order to evaluate the model. So we keep going through that process of training the using training data to build a model and then testing it to see how well it's performed. So the idea here overall is there's not very many lines of code in order to do that, and you don't need to worry too much about learning lots about models to get started, to get stuck in, then try it. There's a lot of documentation in the ML.NET website and lots of samples as well, so you might find that's a good starting place. So just to summarise, a few good places to get started. Azure Cognitive Services is a good way if you're thinking about using facial recognition or speech recognition. I tend to find when I speak to businesses who want to use AI, there's quite a difference between their ambitions. Sometimes companies will say to me, I just want AI on my marketing slides. I want to see I use it because it's a buzzword. That's fine because at least it's honest, and I would rather have that. Okay. So once they tell you that, I can try and find something that's a bit whizzy for them to use. But sometimes I get people saying, I just want to improve a process, but I don't want something that's high risk. So you've got a spectrum between people who want it front and centre of what they're doing, and some people that just want to improve processes. But the idea is Azure Cognitive Services, I think, is more towards the people that want whizzy and want something really cool and very visible. But then you've got ML.NET that's allowing you to try and capture and embody those low-level processes and automate them. So it's about increasing functionality as well. Then we've got the Windows AI platform, and it's basically an integrated stack of technologies built into Windows 10. So we'll start to see AI becoming more and more visible, so that's why it's a good idea to go in it. Each layer, I hope you can see this in the screens better, is got a very specific purpose, but it's putting them together that allows you to have the practicality and the performance of everything in one place. So WinML sits at the very top of the stack, and that's the API for integrating machine learning models into the applications. That's the bit you actually talk to. And underneath that, you've got DirectML, which is about hardware acceleration for ML workloads. It's interesting because you see in Azure, they've got GPUs. The nice thing about them, I think, is it's really about allowing you lots of processing power if your models become really intensive. GPUs were originally used by academics and researchers, and then they started using them for deep learning and machine learning, and suddenly the industry looked at it and thought, hang on, that's really clever because GPUs were never really intended for that, but they are now, so that's good. And we do see those in Azure virtual machines. So then at the very foundation, you've got the compute driver model, and that's the abstraction layer that allows you to abstract away from different hardware types and vendors. So it's that portability as well of the code, which is important, I think. So again, using that, WinML is a load, bind, and evaluate workflow. So we load the model, we bind the model, then we evaluate it. But the takeaway point here is that actually you don't need that many lines of code in order to get started. And I don't know how you learn to program and how you do things. I tend to go and try it, then apologise because I've broken stuff, and then you reinstall it usually and try again. And because I learn by doing and breaking usually, and then moving forward. Some people learn by reading, some learn visually, but I have to go in and just try it. I've not read a manual since about 1998, I think. I'm one of those people. Technical manual, the first thing to go. Remember, you used to get those with CDs. Okay, so following on from the portability, there's something called an Onyx model, which is a standard model format. And there's many ways that the Onyx model is the result of the work that you've been doing when you're coding. So the Onyx model allows that portability between various platforms. So you can use the Onyx models, use that with WinML. You can use it for things like custom vision, which is part of Azure Cognitive Services. It allows you to create your own image classifications by uploading labeled images. So in the images that we used in that quick demo was about a number and then a label to say what the image actually was. So an image of a number 3 and then a label associated with it that was simply number 3. So what we see there is when you're training the models, you're giving it lots of images. It's trying to work out the patterns in the image and how those are associated with the labels. There's actually, in case you're interested, you've got neural nets actually in Excel, believe it or not. People don't realise they're there. They're called the solver. So we'll go to File and then go to Options, then go to Add-ins, and I think it's under the .com object add-in. There's one there called the solver, and that allows you to use neural net technology in Excel. So if you just want to see something in a very safe environment, just go and try that. It was invented by the guy one of the gentlemen who invented VisiCalc, which is now Excel. So lots of fun to be had. AI is everywhere, so it's good to get started with it. So we've got WinML tools as well. And that allows you to have a framework like TensorFlow or Keras or any of the other sort of frameworks that don't directly produce Onyx models themselves. So that's offering that translation piece in order to help you to produce that portable model. And then you've got Azure Machine Learning as well. Azure Machine Learning is a really nice way to get started too. It's more of a low-code stroke no-code solution. So if you've ever used something like SQL Server Integration Services or even Visio, which I assume most of you have seen or probably shouted at some point, you have blocks that you put together and you connect them together and you configure parameters. So Azure Machine Learning is much more about that. There's a service really that provides that end-to-end solution, loading data, building a model, training a model, then deploying it. So then what you need to do is once you've built that, is save the model into that Onyx format at the end of the training. And then you can, basically it's a good way to get started because it gives you a model you could then use in other locations. So ML.NET will give you the model as well. So I think what Microsoft are doing here really is it's all about being very portable, and that model, because it's in a very well-known formats for AI, for machine learning, you can use that anywhere else. So it's the stickiness of using Microsoft everywhere, that it's allowing pieces to talk to one another. And I think that's one reason that Microsoft is so successful in these solutions, because they offer that opportunity. So here's WinML, a few examples here. WinML is that top layer that allows your application to talk to everything else underneath it. So at this point, you might want to keep the ML processing close to where the input lives. That could be on your laptop, for example. And so it's about cost effectiveness as well. So it's allowing you to send calls back and forth too. So WinML and ML.NET, they both sound quite similar, but ML.NET provides you with that end-to-end machine learning solution for preparing data, building models and deploying them. And WinML is slightly different because it's allowing you to take advantage of the processor, and it's allowing that layer to talk to different models. So they are slightly different in what they're doing. Sorry. Okay. So just some concepts of machine learning, just before we wrap up. So when I'm choosing these projects, I'm trying to look for a small, successful project, because people hear AI and immediately their expectations tend to go wild because they're thinking of Hollywood movies and so on and so forth. One of my customers said to me, Jennifer, you've not given me a neural net. Now, this is a guy who can hardly use Excel. It's okay. I thought he's probably read a book over the weekend about AI and decided he's going to go for that. And I said, well, the reason for that is your data is really bad, and I'm having to spend so much time cleaning up the data before we can think about the model. And I think people's expectations, his were, oh, well, I just want the neural net to clean up all the model for me and all the data for me. And I had to explain, well, Azure is not a series of gnomes hiding in the cloud where are just going to chunk through your data and magically do everything for you. You still need to do that work about cleaning the data. Never a popular message. But I think the reason for that is we've got something called Amara's law. Roy Amara is an American futurist, and he talks about we overestimate the effect of a technology in the short run, and we underestimate its impact in the long run. So an example of that would be the internet. It was going to do everything at first. Then there was the internet bubble, popped a little bit towards the year 2000, but now the internet is everywhere. It's almost considered a utility. And I think AI will be the same. We're back in this hype phase, and then things will start to calm down a little bit. But then we will see it start to being used everywhere. So I mentioned neural nets earlier, and basically we even have them in Excel. We have an input of data, then we have the results, and the neural net really gives you lots of layers in between the input and the output that give you the results you're looking for. When people think of AI algorithms, they normally think of neural nets because they sound a bit cool and they're inspired really by human biology. But the idea here is they're not always very good for everything. They're very good for outliers. They're very good for exceptions. And the reason I think all this technology is starting to come together now is because we have the cloud, we have lots of different data sources. I think technology is just this is going to be the slowest that technology is ever going to occur. I think as we move forward, we're just going to see more technology and more data and more things. So how do we keep on top of that? And I think it's all about the data. If you understand the data, you can start to use that as a really good starting point to move forward from there. And I see lots of organisations still struggling with Excel, and I think you see laggards and early adopters. I keep having to explain to customers that Excel, they store it in their email usually, and I have to explain that Exchange and Office 365 mail servers are not document storage. We need to pull the data out and do something with it. So then we get deep learning itself. Deep learning is lots of neural nets strung together. That's really what that is. Now that can be very computationally expensive, and that's why we start to talk about the processors. And the deep learning, because it's really powerful, we use that for massive amounts of unsupervised data, of unstructured data. And that makes it a really interesting tool for big data analytics, because in the real world, raw data is often not labeled and not categorized. Okay, it can be used, deep learning as that technology, as a concept, can be used for some really important problems when we look at big data and analytics, including extracting complex patterns from massive volumes of data. Can be used for things like semantic indexing, data tagging, and really simplifying the data. I've got someone working for me at the moment who's a postgraduate in library science. I secretly always wanted to be a librarian, so I'm actually really jealous. I'm an inner librarian at heart. I would have loved that job, but it was not to be. So watching them and the amount of data that they have to deal with is usually a really, really important and difficult problem. I'd only suggest people use their public libraries so they still get funding as much as possible. There's nothing more important really than allowing people the opportunities to learn. And if I had not had a public library, I would never have got my degree probably, and I would never be here. So they're hugely important for people who need them. So deep learning research really allows you to look at specific challenges around data, including streaming data that's coming at you very fast. As we move into a more IoT world, we're going to see more of that. We also need to scale as well, and using lots of data for lots of things. But that doesn't mean you need to start with tons of data. There's lots of data samples on the internet. You can just go and get started with those. Deep learning in particular is very good for interpreting text, images and video. And as we move forward, seeing more of these types of images and videos being used, I think it will become a really important area to know about. We see kids using Instagram and Snapchat, and it's all very visual now. So the world is changing at quite a rate. Deep learning can really help automate and identify objects. We also have the threat of deep fakes as well. So deep fakes, you might have seen there's one recently released with Obama saying stuff that actually he never said. So I think the technology will need to catch up when people create deep fakes, how to capture and identify what's authentic and what's true. Because we need to, when we look at data, we need to keep an eye on what the truth actually is, and that's why this technology is so important. I personally really hate deep fakes. I think they are, even it's the clues in the name that it's a fake and it's a lie, and I think deep learning is one area that we can hopefully try and capture these. I know the US government has set up an initiative just to identify deep fakes, and I think it's great that they're doing that. So what are Microsoft doing? They've got their own deep learning group. They're blurring the boundaries between deep learning and big data and really helping to clear the way forward for high performance analytics. So Microsoft, I would recommend you go and have a look at their deep learning website. If you've never looked at the Microsoft Research website, I recommend you do. They're doing really amazing things actually. And it's used everywhere. It's even used in gaming, if anyone's gaming. But I just would like to summarise at this top really. Any sufficiently advanced technology is indistinguishable from magic. I'm assuming you all know who that other C-Clark is. Yeah. So I think as we move forward, a real criteria for technology is where it becomes so embedded in our lives that we don't think about it, we don't even see it anymore. The best technology in some ways is invisible, because we just kind of take it for granted. And although I don't think AI, deep learning is there yet, I think it can help and empower people's lives. I'm really excited by what I see Microsoft doing in terms of accessibility. So yesterday they released some new algorithms to help you work with immersive readers, to help children learn to read. And some of these children are in difficult circumstances due to maybe we're just trying to be inclusive and bring people along a journey. And it's really great, I think, that technology can be used for such fantastic purposes. So if you haven't seen the Azure Cognitive Services news from yesterday, I recommend you go and look. I just blogged up about that yesterday. So there's so many great things that you can do. So I'll just end by giving you my contact details if anyone has got any other questions. And we're a few minutes from the end, but if you like, we'll call it an end there and you can get to the coffee first. How does that sound? Any questions, I'll hang around first, but thank you all very much for coming.